This is basically what's in store for us today, folks. We are going to talk about the basics of SDBranch. What are the key essential know-how that you need to have in order for you to understand the technology? We'll talk about some of the basic concepts. We'll talk about some of the basic configuration. We'll talk about what the different type of topologies, the branch topology versus the VPN concentrator. Uh, Most important thing, we'll talk about the license requirements because I think for level one partners, level one engineers, they might get a lot of these questions from customer, because when customer is doing scaling and planning and designing for their network, they talk a lot about licenses. We understand it. We'll also talk about the workflow. What is the workflow of SDBranch? We'll talk about some of the basics of the deployment. What are the minimum requirements for the deployment? Once the deployment is done, when your customer comes back to you and says, hey, can you help me out? I have this problem. I don't know how to solve it. What are the basic troubleshooting steps that you need to do? This will not be too complex. We have a list of basic issues which we keep getting again and again as attack cases. We made a list of it. We're going to show you how to troubleshoot it, and basically what are the resources that are available for you as a partner engineer to go solve the problems for the customer. So this is what we'll do. And at the end of all this, we'll also have a nice demo session where you can look at the live demo of how one of our expert engineers tries to solve the problem. He is going to guide you every step of the way on what are the aspects of troubleshooting that he looks into, how he does the debugging. And without further ado, that's pretty much it. So over to you, Helvin. Please go ahead.
Yeah, thank you, Bharat. Hi, folks. So today we'll be looking on to, the SDBranch and the SD-WAN setup from the basics. So uh, we'll just cover off all these items. First of all, we just try to understand what is SD-Branch and the main elements that SD-Branch solution would have. To understand how the setup is and its key features, what are all the subscription types as in the licenses that would be required to have the setup built, and also the topologies that we support, and how we could just provision these SD-WAN solution, and how we could just build the IPsec VPN tunnels between the VPNCs and the branch gateways. And also, we have aligned some case studies that we from TAC have encountered, and we'll be discussing on that part. And finally, we would be, sharing some of the links and documents, and then we'll just move on to the demo on how and where the configuration needs to be done, and how we could just try to troubleshoot. And all that would be discussed during the demo. Moving on to SD-Branch. So as you all know, SD-Branch solution integrates the cloud management with the SD-WAN and the usual LAN routing and everything. Basically, it reduces the complexity in terms of, cost, and also the manpower that we would be facing during branch office deployments. So in our scenario, cloud management with Aruba would be Aruba Central, where we configure everything. We, as in the admin, would be configuring, and on the branch office, even a non-technical person should be able to bring up these devices with our solutions for OTP, or one-touch provisioning or zero-touch provisioning. So this basically, solves most of the issues that is related to WAN, LAN, and branch onboarding. Say for example, if there are n number of branches that a customer is trying to bring up, and with Aruba Central integration on SD-WAN, we should be able to pre-configure things so that the onboarding could be seamless and not time consuming. So, so if you see in here, basic SD branch solution would have a branch gateway, which would be, establishing IPsec tunnel towards, the VPNC, which is in our data center, and all the downlink traffic, say an access switch where our surveillance cameras, or printers, or servers are connected, or any sort of access points, that is IAPs that are serving wireless clients, all the traffic that is intended towards, the corporate could be separately be sent, and all the traffic that is intended to internet could also be, segregated. All that can be done with the SD branch solution. So the key elements, the main elements for SD branch solutions are four, which is the cloud management, branch gateway, hidden gateway, and the virtual gateway. So with Aruba Central, as I said, the cloud management is Aruba Central, which would be the customer portal, and where the customer would be interacting directly on the front end. And this is where all the configuration and everything would be done, so that we could just set up SD branch solution on the branches easily. And then comes the branch gateways, which are the physical devices that we would be deploying on the branch. And downlink to that, we could, very well have a LAN or a WAN setup using, Aruba switches and Aruba wireless APs to serve the clients, and also have, security policies with the stateful firewall configurations that we have inbuilt on the device. And also, it would actually, build tunnels towards your DC data center onto the VPNCs, and the VPNCs are nothing but the hidden gateways, which is the third, key element. That is the one which is acting as a anchor, and trying to route all the, traffic towards the corporate network, and establishing these tunnels, the IPsec VPN tunnels, are also being, orchestrated and automated with our SD branch solution, where the very minimal configuration would be needed. And the fourth one, which is the virtual gateway, which is nothing but, hosting a VM on a public or private cloud like Azure or AWS, where we would be able to, bring up VPNCs on the cloud platform, and have the branch gateways talk to those, virtual gateways, so that the resources on Azure or AWS could be, used by the branch gateway users. Moving on to the key features. So, with SD branch, it has the simplicity of automation, the role-based policy, security, and SD-WAN, integration. Basically, the automation part comes in with Aruba Central, where Aruba Central is where you would be managing all these SD branch solutions, be it an access point, SD WAN, controllers. Um, so a very minimalistic configuration would be done, and the bringing up of devices is all automated. And once you bring up those devices, real-time health monitoring can be done on Aruba Central, where we have separate pages where we could overview the health of the devices, be it a branch gateway, be it a VPNC, be it the users who are connecting to the devices, the uplinks, the CPUs, everything can be monitored. And then comes zero touch provisioning, where, as I said earlier, I mean, so we would be just be adding for say just to give you an insight, we would just be adding the MAC address and the serial number of a device that you would like to bring up on Aruba Central, and with the right subscription and a device being added to Aruba Central, all that a person on the brand side would require to be doing is that just connect the device, say a branch gateway to I mean port where we have internet, and once that is done, everything would be automated and a zero touch provisioning can be achieved. And then comes the SD-WAN orchestration, where orchestration, as in the IPsec VPN that is built between the VPNC and the branch gateway to pass the traffic using their uplinks. So everything is just a knob, and once you enable that, we should be able to, I mean, build the tunnel, and all the routing part is also taken care of by orchestrator. And then comes the role-based policies. I mean, whatever policies that you create could be utilized across board, where it can be used as on wired, wireless, and WAN, and also application level fingerprinting, where we could restrict users in terms of I mean applications that they would be using, and and then comes policy-based routing, where we could set policies, unlike the usual destination-based routing. We could have a certain set of policies. Say, for example, one uplink, you would like to have the users to get directly to the internet. And one uplink, you would want to have the users to go to the corporate, say, MPLS, I mean, uplink, where all the traffic should be, I mean, routed towards that uplink, and it's all can be done through the policies that we could predefine. Then comes the security, where we have IPsec VPN, which is nothing but the VPNC to branch gateway, or branch gateway to VPNC, IPsec VPN that is being done. And the client VPN, where we do have solutions, as you guys know, via VPN. And if, say, the user is, I mean, a remote user, and he wants to connect to the corporate network on the data center, and he could use the via client VPN and try to connect to that DC. Then comes dynamic segmentation, where we can very well have, um, I mean, users segmented in a specific way. We could use ClearPass. We could integrate ClearPass to have, I mean, segmentation for users, say, guest users, I mean, corporate users. All those segmentation can be done. And also the usual stateful firewall, I mean, support is there, and the WebCC is there, where I mean, we use our own cloud at the backend, Bright Cloud, where we use the signatures, known signatures, and the reputations, and we check the trustworthiness. And if it's a trustworthy, we allow the traffic, I mean, the web traffic for the users. And we do have a cloud security integration, where say, for example, customers do not want the inbuilt firewall support, and they would like to have external firewall integration, say Palo Alto or Zscaler. So those integration can also be achieved, so that all the traffic, I mean, screening can be done on the third-party tool. That can also be done. And SD-WAN as such supports SAS and IS acceleration, where we have path quality monitoring. And in the UI, we could just very well see the quality of the uplinks. And also, we could just set the dynamic path selection for the uplink, and what type of, I mean, internet traffic needs to be sent towards a specific uplink. All those configs can be done. And we do support our routing, the usual routing with BGP, OSPF, RIP, and also static. Um, we could also have uplink compression set to, I mean, attain bandwidths. And also we could just set bandwidth contracts on the uplink and also for the users. So these are the key features that SD branch has as such. And then comes the subscription types. So as Bharat rightly said, customers might not have an idea on what type of subscription that they would need, and we have some, 5 sets of subscription types where we have a specific support or features that each subscription would be capable of. So first comes the foundation licenses, where these subscriptions can be applied to all type of devices except for the virtual gateways. So be it a 72 series or 7000 series or 9000 series, it doesn't matter. And the foundation subscription will have all these key set of features that would be applicable. And a foundation base capacity license would be applicable only for the 7000 series and the 9000 series gateways, where we do have set of restrictions on client support. Say there is a branch where you don't expect more than 75 users, then we could very well go for foundation base capacity, where all these foundation license capabilities would be there, but it'd be restricted to number of clients. And also it is just supported on 7000 series and 9000 series. And we do have advanced subscriptions where on top of the foundation license, we can have these set of features. It totally depends on the requirement the customer has, and if the customer would like to have Zscaler integration, or he would like to have a BGP support and all that, then they might have to go for advanced subscription. And advanced base capacity, as just like foundation base capacity, it would be applicable only for 7000 series and 9000 series branch gateways. And they do have client restrictions, a number of client restrictions. And then comes the virtual gateway licenses. These would be applicable for the virtual gateways that we host on Azure or AWS kind of platform. And we have contracts for one year, a 3 year, or 5 year period. And also we do have a bandwidth option on the VM for 500 Mbps, 2 GB or 4 GB. And this too totally depends on the requirement. On top of these, we do have something called with security. So foundation with security, foundation base with security, advanced with security, advanced base with security. So with security, as in we do have an option called IDPS, so intrusion detection protection services. So those capability would be added to these security subscriptions, and it depends on the requirement basically. Moving on to SD branch topology. So this is a basic topology just to give you an idea of how SD branch solution would look like. Um, so we have Aruba Central, which is the front end for the user, a cloud management front end. And there is, there will be a DC data center where we have a certain set of, servers or VMs that the users on the branch end would be needing to access. And we have switches and VPNCs on the DC. And say if we have a SD branch solution on a high utilization, branch, where we need to have branch gateways, and on the downlink we have a switch, and for the wireless users we have wireless APs, the IAPs, to serve the clients. And to medium to small branches, we could very well use the um, IAPs to establish the VPN tunnel towards the VPNCs. So that could also be achieved. And also say if we have users alone, remote users or telecallers who would like to have corporate access, um, um, then they could use VIA as a tool on the client VPN perspective, and then they could build a tunnel. So this is very much on the generic or a basic SD-WAN topology. So when we, then we move on to zero touch provisioning. So say we have a new device, say a branch gateway, and if we have a non-technical person at the branch site and all that, we would be requesting a person would be to have a device connect to a specific port where we have internet access. And once that is done, and when we have all the presets that is configured on Aruba Central by the admin, so first thing the device would be doing is getting an IP, doing a DORA process, and once that is done, by default, all these gateways would be doing, it'll be trying to, resolve device.arubanetworks.com, which is nothing but our backend inventory, that is Aruba Activate. Once the DNS resolution happens and once it tries to connect to the Aruba Activate, the device takes its serial number, MAC address, model, and version as in the software version that it's running. And once it reaches Activate checks, the gateway inputs and also the firmware which is installed. Say if the gateway is running an old code on 6.x, and what we normally do is that from Activate, we do have set of predefined rules where we just have the device to get the code just like how we have it on the AP controller scenario, where the AP would be downloading the code from the latest code that is running on the controller to fetch the code and then reboot and then come up. The same way, the gateways would be fetching the code from Activate through our cloud, and then it will reboot and then come up with the actual SD-WAN code. Once it comes up, Activate would redirect the gateway towards Central with a set of predefined rules that we already have on Activate, where it would be of MD to Aruba Central, MD as in the branch gateway towards Aruba Central. Once it tries to reach Aruba Central would check for the serial number, MAC address, model, and the certificate. So the certificate, as in the inbuilt certificate that we have, which is a TPM module certificate that would be used, and it gets authenticated on the Aruba Central end. Once the device talks to Aruba Central, and if we have all the device level configuration and group level configuration predefined by the admin, the device would fetch all the configurations and come up online on Aruba Central. So, uh, so here, from the non-technical perspective person, all that he did was trying to connect a device to a internet available port. Once that is done, the device came up. All the backend work is done by the admin on Central. So zero touch provisioning for the user is being done. Then comes OTP, which is one touch provisioning, where we just need a console port and console port connected, and have the boot get on to static Activate, where if there is specific requirement for users to have a PPOE settings that needs to be added, or in some cases customers might need to connect to a trunk port to forward the traffic, and all those configuration can be done with static Activate. See, for example, on the branch gateway, if a customer wants to have a PPPoE connection, he could give in the credentials and all that, and then bring the device up. So this is a one-touch provisioning. And then on the VPNC side, if they want to have a trunk configuration, they could very well have the configuration set with static or a PPPoE connection, anything of their requirement. And but this needs intervention through console, and for this we might need some technical person on site. Then comes manual provisioning. Manual provisioning would mostly be done by, I mean, TAC or AS or QA at our end, where we usually, I mean, have testing setups where we try to move devices between different Aruba Central, I mean, servers for our testing. So, I mean, just like how we do it on Aruba normal controllers end. So once you just, if you go in here, right, so we do have something called full setup. So once you do a full setup, the initial script would be more like a normal Aruba controllers, I mean, initial script where we given all the details. And when it comes to master switch, we would be giving the actual node URL on whichever server that you would like to have these device, I mean, come up. In our scenario, this was taken from internal server. Internal server is just for our Aruba, I mean, needs and for testing, and this is not for the customers. And once that is done, we would also be giving the switch type as ACP, which is Aruba Central managed. So once that is done, we could very well set the, I mean, VLAN and IP assignments as per needs. Once that is done, so this device can be brought up on any of the nodes that we would like to have. And in some cases, partners might also have some kind of scenarios like this where customer would like to move it to different, I mean, node URLs. This can be done, or if you guys have any kind of issues, we could very well work on the back end on the same. So these are the node URLs that we currently have for different servers that we host for Aruba Central on different zones. US, there are two, and APAC, we have one, and we have one for Japan, and we have another one in APAC South, and also EU. So these are the different URLs that can be used during manual provisioning as per the requirement of the customer. Then comes the VPN. So VPN establishment is between the branch gateway and the VPNCs. And I mean, I mean, on Aruba, we have an architecture where we have hub and spoke architecture, where VPNC would be the hub and the branch gateway would be the spoke. And there will be a VPN tunnel that can be that needs to be established either by manual configuration or by I mean orchestration, and that can be achieved using I mean we used I mean IK version 2 to have the users, I mean the user as in the devices to authenticate among themselves, where we use, as I said in the previous slide, we use the TPM certificate by default, and if you need to have I mean custom certificate that needs to be uploaded, that can also be done uh, on both ends, where the client cert and the server cert exchange would happen on the back end. So as I said, SD-WAN orchestration happens um, between the VPNC and the branch gateway, where we have two sets of, I mean, uh, orchestration that can be done. One is tunnel orchestration, another is the route orchestration. And when it comes to orchestration, everything is automated, and we do recommend I mean orchestration method I mean to the customers, but if there is any specific need to have manual, then they could very well go ahead. And tunnel orchestration is overlay tunnel orchestration OTO and overlay route orchestration ORO, and this is supported from Aruba Central on 249, and the device firmware should be minimum of 1061. So currently, the Aruba Central servers are getting upgraded to 252, and most of the, servers would be upgraded to 252 by this week. And we are, running at 2005 and 2.1 codes currently. So this can anyways be achieved on all the latest codes. So when it comes to tunnel orchestration, say for example, we have a cloud gateway and we have a DC and we have a branch, and the branch has multiple uplinks, MPLS, INET, and LTE connections. And using the topology policies, we use the types. So basically, we could set, types. Say, for example, the branch gateway is the source and the destination is towards the cloud gateway or the hidden gateway. We could set what type of, uplinks that needs to be used, predefined. So there is a specific application for tunnel orchestration that can be used. And when it comes to route orchestration, it does use tunnel policy, topology policies. On top of this, we do use route policies where we have a set of routes with the right number of costs that been added with some tags. For example, if the user would like to have access to the ERP system or IoT analytics or anything. So right set of uplink can be used to access, be it on the cloud end or be it on the head end gateway end. So all this can be done through predefined route maps or routing, predefined routing that has been added on the overlay end. So once orchestration is done, when you go to a branch gateway and try to do a show IP route, you would be seeing, routes that shows BC, which is the overlay, route that automatically comes up. So this is also automated, and we need not intervene in any way. So this can be checked. And on the VPNC side, say I have, four branches. So we could very well check the same on the VPNC end on the show IP route, where we could just see the BC, which is nothing but the overlay protocol that is happening through cloud. The routes are auto-generated through orchestration. So there are a few sets of useful commands that we could just check on the VPNC and branch gateway end, like show IPOAP, show IPOAP route, and a tunnel and advertisements. These would give more details on the orchestrated routes and the tunnels that we already have established. Then comes policy-based routing, where unlike the usual destination-based routing, there could be scenarios for customers where they would like to have set of policies that needs to be, put in for, forwarding the traffic to a specific hop. Say a common use cases like specific subnets. Say a guest user traffic needs to be routed towards internet directly. Internet uplink as in INET uplink, and not use the MPLS, where it has routes forwarding towards the corporate. And there could be scenarios where customer would need full tunnel, where all traffic should be routed towards the corporate DC, and over there they could use any kind of third-party tools like UTMs, Palo Alto Zscaler kind of on-prem appliances, where the screening can be done for the users on the DC end. So this is all been predefined, and if you want to have a set of next stops that can be next stops that can be predefined on Aruba Central, And once that is there, we could very well have the same mapped onto policy-based routing. So, so this is one of the case study that we encountered during our troubleshooting, where I mean using PBR. So a user in 192.168.3 network, which is a client, was trying to access destination address, which is the voice server, which is an 8.36 network. Ideally, as per the config, it should take 0/0/1 main port and reach the server. But there was a issue that was reported by the customer saying that there are traffic that are hitting from the user on port 1/6 on the firewall, which is not an expected behavior. So issue was raised, and during our troubleshooting, what we saw was that we tried to do a show data path session table with including the server IPs. And when we did that, we saw that when the source IPs are the voice server IPs, we saw multiple port numbers that are being used by these servers, and that wasn't the expected behavior. So we tried to grep with one specific port number that is being used. And what we saw was there were two different transactions, that is four transactions, that is between once one there are two, so server IPs. One is 198 and 200, and the device was trying to communicate with just 198, but still there was a response that is coming in from 200, and that was also happening on the same port, which is not an expected behavior. And during our troubleshooting, what we found out was that the server was trying has an option to sync itself, more like a stack, where it could just respond back to on both the IPs, which was confusing. And that led to the routes that are going in through a different port, which is not intended as per PBR, and the input was coming in from uh, the voice server end, which we did not initiate. So we generally, check for the initiation that is happening for the traffic initiation that is happening from our end. So not from the outside. That is, say in our scenario, the voice server. So then ideally what happened is that we had to work with the customer on the server end, where there were options to make the devices sync, and once that knob was removed from the voice server end, everything started working. Then comes dynamic path selection, where we could set specifications for the interesting traffic that needs to be routed to a specific uplinks. Say we have three different uplinks: MPLS, INET, or data card. So specific interesting traffic could be routed to a specific uplink, and that can be predefined, and that also checks for sessions. We have a set of rules that could be applied, and on top of that we have SLAs that can be applied, and then on top we have WAN path selection that could be added. So it would be checking each criteria, and if everything is applicable, that would take that specific route. Say a WAN path selection, we have options to choose a primary or a secondary. It totally depends on the requirement the customer has. And as I had explained in previous slides, guest traffic should route through the direct internet uplink, and the corporate traffic that is going towards the corporate network on the VPNC and DC end, that can use the MPLS route or the uplink. So all that can be predefined, and also once traffic comes in from one specific uplink, from the VPNC end, the return traffic would be towards the same link, and where we have reverse path pinning. And it's the other way around too, where from the branch gateway, if a traffic is going out to VPNC, it would be on the same uplink on both transaction, because the active sessions are always being cached. So another case study on DPS, where we had a load balancing with the round robin method enabled, and it wasn't working as expected. So ideally, as per the WAN path selections, once we have the set of rule and SLA, we primarily gave, both the MPLS links, where load balancing was enabled, and that's why we see both on primary. So what happened is that when we saw showed it about uplink earlier, we saw that MPLS 2 was taking more of sessions. It was showing around 87%, which wasn't expected, and load balancing wasn't happening. And during a troubleshooting, what we saw was that the customer had set a weightage for different uplinks, and weightage takes more precedence, and that is why the issue was happening. So what we did was we removed the weightages and set equal weightages for all uplinks, and after which, when we saw showed it about uplink, we saw that the distribution was happening fine as per the config that we have for WAN port selection. Then come dynamics segmentation for SDBranch, where we could very well have ease of provisioning using a ClearPass or any sort of servers, where we could use both wired and wireless. Wired as in the Aruba switch segregation, where we could have set of users to use or segregated access to those set of users on the wired, and also on the wireless end we could have the same kind of segregation or the segmentation that you could say. And we can have security features that we have on wireless on wired too, like DPI, all types of stateful firewall policies that we could just apply, and we could have application level segmentation for specific users. We do have predefined application level fingerprinting, and also custom can be created, and we do have device fingerprinting that can be done both on ClearPass. So another case study is that during branch gateway failover, we saw that the failover was taking more time, and the dynamic segmentation that happens on per port tunnel node, that is on switch, wasn't working as expected. So basically, switch 1, when it fails, and switch 2 takes over, and after branch gateway comes up, and this at this point of time, the traffic was not being forwarded for the WAN side, in a quicker way. It was delaying, and that was causing issues for the customer. So what we noticed is that the keep alive intervals that the customer had set was higher, and because of which the preempt was taking time. And then after a discussion with our dev and also checking the configuration, we got to a conclusion, and the recommendation was given from our dev saying that we could disable preemption, so that once the branch gateway 1 comes back up, the failover is not happening immediately. And there was a test that was done by a QA in our QA environment with 100 IAPs, and keep alive set to 1 second, which is the minimum, and everything worked fine. And another recommendation that we generally give is that to use the physical IP for the controller and the backup controller when it comes to tunnel node servers instead of VRRPs. So once we set the keep alives to 1, and the failover was just happening, readily, and the user's traffic was able to be forwarded readily within a second. Another case study is that during PPT and the per port tunnel node perspective, where we segregate, users. What happened is that in a scenario where the customer accidentally connected another, connection or a link towards the switch stack, which created a physical loop, and the total network was brought down. And we from SD branch, SD-WAN solution, we do have a specific knob that is tunnel loop prevention, which is by default disabled. And what we did was we had to enable this, to avoid these sort of loops. And this is not available on WebUI as of now. So this would be coming into picture, on WebUI very soon. In 252, there is a, integration pipeline where this has been put in. But for now, we wanted to highlight this because there could be scenarios where, a loop can occur on a customer setup. So to avoid these scenarios, what we need to do is we need to get into the disaster recovery. So if you first get into a tunnel node database, you would see that tunnel loop prevention is disabled, and on WebUI we don't have an option to enable this. So what we do is we get into the disaster recovery, and once we get into the disaster recovery and we enable a tunnel loop prevention, and once that is done, these sort of loop prevention can be done, and this can be achieved. And very soon we'll have this knob on WebUI too. And then comes branch redundancy, where we I mean, can achieve, uplink redundancy for the branches. Say we have two branch gateways that has different uplinks, and if in case, a branch gateway, once uplink goes down, all the traffic that is routed for the users cannot be, go out of the first branch gateway. So to achieve redundancy between the branch gateway and to have seamless forwarding of traffic for the branch gateway users, we have a set of branch gateway redundancy options, where we could use VRRP, traditional VRRP for the LAN redundancy. On top, we could have HA configuration between the branch gateways, where we establish a virtual uplink between the two branch gateways, where say, for example, let me just move on to the picture. Yeah, so this would give you a better idea. Say there is a branch gateway 1 that has a MPLS connection, and that is on VLAN 4093, and there is another branch that has a different uplink on different VLAN. So what we do is we do a VRRP on a specific, VLAN, and then what we do is we set the HA, and once we set the HA, a virtual link between the branch gateway 1 and branch gateway 2 is achieved. So when we check the, so this is the, configuration that I was talking about. We try to give the peer on the branch gateway 2, we give the branch gateway 1 IP, and on branch gateway 1, we give the branch gateway 2 IP. And then we, this is the VLAN that would be shared between these two branch gateways. Once this configuration is pushed, a HA is achieved, then we would be able to see a virtual uplink that is formed between the branch gateways. When you do a show uplink, you will see this. And so what it basically does is, if in case this particular MPLS connection for branch gateway goes off, the user traffic which is on the downlink can be forwarded through the virtual uplink towards the branch gateway, and this would use the internet traffic, and all the traffic could be routed for the downlink users on branch gateway using this particular internet access that is there on branch gateway 2. But to do so, we do have a set of criterias or set of conditions that needs to be there, and the uplink should be a WAN link on both ends, and both uplinks should be on different VLANs, and it should be trusted. So these are the conditions that needs to be taken care to achieve branch gateway redundancy. And another case study that I would like to discuss is about SIP calls that was not working between two branch gateways, where say I have a branch gateway 1 and branch gateway 2 on different branches, and a caller is trying to call from one branch to another branch, and all the traffic is routed towards VPNC, and behind the VPNC in the data center is where the server, voice call server is there, and the traffic wasn't getting forwarded to branch gateway was the issue. And then during our troubleshooting, we observed that SIP calls do not work with NATing. So what we did was we do have an option called allow transmit inter-branch connectivity. So we enabled that on the overlay, which helped to forward the traffic between the branch gateway, so that the SIP calls could be forwarded and the communication was happening seamlessly. So another case study that I wanted to highlight, this more of a general case, general recommendation, I would say, where when it comes to, WebCC or application visibility levels, we normally recommend to have a WebCC enabled with deep packet inspection, the DPI. And as I had initially said, when it comes to WebCC, we use our Bright Cloud signatures and the reputations to check the trustworthiness. And if there is any kind of issues, we normally request a customer to collect these set of outputs, which will help us to debug further. And the general recommendation would be to have the IP classification reputation enabled with inbound and outbound malicious IPs that is being denied. So this would help us in trying to, check the web root on the reputations and the signatures on the Bright Cloud, and the trustworthiness of the web traffic could be checked using WebCC, and this would help us whether if there is a break on WebCC or not, and check with our dev if needed. So then comes the useful links that I was talking about, and the documentations. So you can use datasheet. This is more brief, note on SD-WAN. And then you could check the community link, where you could go through all the fundamental things, which is more of a VRD. And then there are help forums for central, where you could just check the SD-WAN documents. And I would say, if people are very interested with videos, you could just check these YouTube links that's been created by Aruba for SDBranch from scratch, which would be helpful for hands-on too.
Helwin, just to let you know, we have 10 more minutes for the lab demo, okay?
Okay. Okay, so let's move on to the live demo, so that I could just at least try to explain what are all the options that we could use and that we discussed. So as soon as you log into Aruba Central, so this is our internal portal. Okay, so as soon as you log in, you will be landing onto your account home, where you can check the network operations and all the settings that can be done. So the first thing to bring up a device on Aruba Central for the admin to do is to have get into key management. Once he gets into key management, this is where he would be adding the subscription keys. So as we spoke, about the foundation licenses, foundation base, the advanced licenses and everything. So all that keys would be added here, and once that is added, you will be able to see the number of available device subscriptions and what type of subscriptions are being added. So for gateway, the five set of licenses, subscriptions that I was explaining earlier, those are the ones. And we do have licenses for devices, that is devices as in IAP or switch. And also we do have service licenses for a different set of services like cloud guest, or you could just have proximity sensing and everything. So different set of subscription can be added here. So once that is done, you go back to the account home, and this you get into device inventory. This is where you would be adding the device, a specific device, say a branch gateway, and that can be done, as I said, just with the serial number and the MAC address. So once this is done, so if you can very well have a group assigned for the device from here. And also you could just check whether the device is subscription is assigned for a device or not. And if it's unsubscribed, you'd see it in red, and if it's subscribed, it would be on green. So once you had successfully added the device on the device inventory for Aruba Central, you would be going on to subscription assignment, where you would be assigning the subscription for the device. So for gateway, we deal with this particular subscriptions. And if you just see, once you add the device, the device would be showing up as unassigned here. So once you assign a specific license, be it a foundation license or foundation base, and foundation base with security. Security is something, as I said, it is a additional feature for IDPS, and as per the requirement, this can be mapped here. So this is where you add the subscription under subscription assignment, and you could very well see the available licenses here once you add. And also we have virtual gateway assignments that I was talking about. VGW licenses, subscriptions, which once you have it added on the key management, it would show up in here. So once you have the device added, and you could very well have the mapping done here. So currently I don't have any virtual gateways, so you don't see those devices. So these are the two that would be needing for SD-WAN on the gateway perspective. And we do have other subscriptions, as I said, the device management subscriptions, that is for access points and switches, which can be done here either by auto subscription or by manual. And also, as I said, regarding the service subscriptions that can be used for Clarity or Cloud Guest or Presence Analytics. So all you'd be doing is drag and drop the device that you had added. Once that is done, you move on, and before moving on to the network operations, say if you want to have your users to be added to administrate Aruba Central or SD-WAN, you could very well have the user added here. The username would be the email ID and description, whatever you could give, and you could choose the language, and you could just add the user. And this particular user role adding would be requested by TAC engineers at times, depending upon the issue that we face. And and basically we request for access to the account so that I mean we don't work on calls and use the valuable time of the customer. Instead, we work on the back end, and if needed, we could just work with our dev with the access to the Aruba Central access. We could just check the issues. And we could save time for the customer. That's what we generally do. But allowing access totally depends on the customer's security policies and everything. So moving on to network operations, this is where all type of configurations can be done. So before moving on to configuration, I would just try to showcase um, the outline of the views that we have. So this is the global view where we could just check the gateways that are available, and we can have access points and switches on a specific group. Whichever that we are creating. And this is a global view, and if you just do a drop down, you'll be able to see the number of groups that you have, and you could set sites to segregate different sites that you have on different locations. And say I want to have, so once you've added the device and you've given the subscription and everything is done, and before the user tries to have the gateway connected on the branch end. So you could have a predefined set of, um, a group that can be created where a group level configuration can be done. Say, for example, I'm doing creating a group called demo. And while creating a group, we do have options to support template groups for IAP and also for switches, where if a customer wants to have uh, large set of branches or devices that needs to be brought up with the same set of configurations, that can be done using template group. And if not, you could go with the general one. Say I'm giving in I'm creating a new group. Okay, once this is okay, just a minute. So once we create the group, so we could either, so once the device are so initially when the device comes up, it would be on unassigned device. If not, even before the device is brought up, we could just have the group defined. And as soon as the device comes up in here, we could just we could just drag drop and assign the group for the device. Once that is done, and we move on to the group. Say, for example, we create a demo test. So on the group level, we could do configurations for be it an access point, which is IAP switches or gateways. And when you're going to config, so this is where you do the configuration. When once you click on config, on a new group, when you create, it would pop up a message whether this group is for the branch gateway or the VPNCs, because different set of configuration would be available for different set of groups. Say if I'm choosing branch gateway and saving, so you can just skip the guided one so that it'll be easier for now for me to explain. So if you just see the group, right? So this is the group level. If you just move the cursor here, you'll just see that we are in group. And one more, place where you could just check in what type of group is this is. This is a branch gateway group. So you could just check in here. So, and to do the configuration, we generally recommend to have use of advanced mode, where we have all set of configurations that can be done. So let me just use the group that I already have. So this is one of the branch gateway that I have. So this is the list view where we can have, I mean, the number of gateways that is available. So this is one of the gateway that is up on central already on my setup. So this is the group view, and when you click on the the device from the device view, you would be seeing that if you just move the cursor, you just see that it's a gateway, and you are on the specific device. And once you go to device, this is where all sort of configurations can be done. You would see that this is device type. So earlier it was in group type, and now it's in device type. So which means that all the configuration that we do in here is all device specific configs. So these are the views that that can be seen on on an overview. To bring up the device, first thing that we would recommend is to have system IP address configured, just like any other devices. So to have a system IP, just get into the interface, and you have a set of port, and you could set the port as an uplink, or either as a WAN, or the LAN. So once that is done, you go to the VLANs, and you set the VLAN. And once you set the VLAN, you could see that a static configuration is there, and you can have static configuration or DHCP or PPOE configuration as per your need. So once that is done, you could very well go ahead and go to the system and have the VLAN mapped in here. So system IP is done, and another key element would be DNS. And on DNS, DNS, where we could just try to give in the DNS server IP for the device, where it uses it for the resolutions. And just to highlight another point, on the group level, for system IP, we could very well use a pool, a gateway pool, where, say, if we have a set of branch gateways that needs to be brought up on the Aruba Central on SDBranch, we could set predefined pool for the gateways. Let me just show you so that you'll have an idea. We have to go to the group level, as I said. See. So once you go to the, group level, you have something called gateway pool, where you could just create the pool. And once you create these pools, and under the interfaces, under interface port, on the VLAN, if you go, you will see the, specific option to have IP address assignment that can be done with using gateway pool. So whenever a different branch gateway comes up, it will use the IPs that are allocated on the pool, and everything would be seamless for in terms of allocating IP address. And then a key information would be to have the a default gateway that is set. So the default gateway you could just add in here under routing for the specific device. So if, when I go to the specific device, under the device configuration, if you go to the advanced mode on routing, you can set the specific IP addresses that you need as a default gateway. Once this is done, your device, when the non-technical person or a person on the branch tries to connect the device to internet's available port, then the device, as I mentioned, it will talk to activate. From there, it will talk to central, and with these set of pre-configurations, the device would be able to come up. Then to just give you a quick, I mean, hands-on. So let me just go in here for the WAN. So the WAN compression part that I was talking about and load balancing, everything can be done under the WAN tab on the uplink. And we do have a dynamic path steering that I was talking about, where we could just set the rules. So for example, so we can set, say, I'm just giving any for just for testing reason. So then we could just set the SLA, as I said, we could just use the existing SLAs and set the latency, jitter, um, and also the loss and utilization as per the requirement, or we could just create new SLAs with the new name. Then once it is done, you could just set the primary and the secondary path. So we could just set, so this is one of the uplink that I have. So you could just choose, or you could just choose any of the uplinks and try to have predefined path steering policies for different uplinks. And then so we can have GRE tunnels that can be established if needed. Say, for example, you want to have a trust anchor controller scenario to forward the traffic for the guest. That can also be done. And under security, this is where I was talking about the policies that we can create that can be applied for both wired, wireless, and all these policies can be used on specific roles that you would like to create. So the stateful firewall capabilities or all that would be available in here. And the application, level segmentation that I was talking about. So uh, these are the predefined application limits that we could just set. So if you go in here and check the predefined applications, or whichever it's there are more than, thousands of application predefined. You could set the restriction in terms of application level, and also you can have custom application that can be added. And under application visibility, this is where WebCC, DPI, and all comes into picture. So and as I said, the general recommendation is to have DPI enabled and IP classification reputation enabled with the inbound and outbound malicious IPs denied. And one more thing I missed out to update is that we do have option to have geo-based, location restrictions, where we could just very well have, any set of countries that we could add. We could just set countries, and if you think that there are traffics that are coming in from a specific country which is not integrated to your network, so you could just very well block these traffic that is coming in from different countries. That option is also there. So all this would be under application visibility. And then moving on to the VPN. Yeah, so this is the orchestration that I was talking about, the overlay orchestration that I was talking about. So we do have two options, manual and orchestrated. So manual, you could just try to give in the manual details, or if it's orchestrated, which we generally recommend, we just have to enable, so this is already enabled. So once you enable the IPsec VPN would be automated, and the routing and everything would be automated between the VPNC and the branch gateway. So once, this is the orchestration part that I was talking about. And once that is done, and if you want to have any kind of routes that needs to be added, or policy-based routing that we discussed, if there is any kind of policy that you would like to add, as a predefined one, you could just very well go ahead and add the policy and apply the applications that will be allowed on a specific uplink, and you can use the next stop configuration that is that can be configured and mapped to the policy-based routing in here. And the usual routing for RIP, OSPF, BGP is available. And if you want to redistribute the routes to the overlay, you could just do that in here, where you could just choose the available connected static or OSPF, BGP, whatever configuration routes that you already have. And if you're choosing connected, you could just choose any one of the, VLAN, that you would like to distribute across the tunnel. So that can be done in here. So then comes the high availability, where this is what I was talking about for the branch redundancy, where you could just set the VRRP configuration, and for the WAN redundancy between the branch gateway, this is where you give the peer IP and set the peer gateway VLANs. So this is what would be used to have the redundancy, the HA redundancy between the branch gateways.
Sorry, Helen, we are now 5 minutes
Yeah,
overrun. So
I
can you wrap up in 1 or 2 minutes?
yeah,
We can give.
I'm almost done. Yeah, I'm
Okay,
done
sure.
actually. Yeah. So let me just move back to the slide. So if you guys have any questions, you could just ask. Yeah.
All right. Okay. Thank you so much, Helen, for sharing with us all the very insightful and very practical experience with us. So without further delay, then I would just want to launch the poll here. Just take you 1 minute. Please provide your honest feedback to us, and we want to improve our next webinar. That's to cater your real needs. So I would just take you 1 more minute here. To fill in all the questions we post, the survey we post here. Just take you 1 minute. And then meanwhile, if you still have any questions, you can post your question on a Q&A panel, and Akel will be standby here to give you the answer. Okay. Looks very positive. Thank you so much for all the feedback here. Okay, I will end the polling here. Okay, Bharif, do you want to share
Sure.
the last 2 slides? Just
Yes.
very quickly one through.
All right. So once again, thanks everybody so much for attending. Here we have some resources for you to use going forward. We can use the Airheads community, the Arubapedia, and the partner networking portal. Helmi, can we please go to the next slide? We'll talk a little bit more about the Aruba Quotient for partners. It's a mobile app, and it's available for download in Apple App Store as well as Google Play. More information is going to be available for you in the recording and in the deck. So please go ahead and refer to it. And once again, thank you so much for being a fantastic audience. It's been an absolute pleasure for us to deliver the session to you. Based on your needs and your feedback, we'll continue to go ahead and deliver high quality technical webinars to you in the coming months. Please look forward to it. And we really, really appreciate your time and support in attending this session. Thank you so much, everybody.
Thank you, everyone. We will end the session here. All right. See you next month. Bye-bye.
Bye-bye. Thank you, guys.
Thank
Have a
you.
great day. Bye.
Bye.